Alright, so this lesson is slope fields. It's not a specific number in your chapter 6 sections because it runs kind of throughout the whole section. So today we're going to talk about what a slope field is and why we even need them. So first of all, we're going to look at how do you create a slope field. And you can see over here to the side that I've got this, it's kind of like an XY plane with some dots on it. So basically we're just going to put some slopes. We're going to estimate some slopes and draw them. So we're just going to kind of go through this. Notice that your dots only go from -3 to +3 on the x-axis and -3 to +3 on the y-axis. So we're not doing a whole bunch of dots. The more dots you do, the better your picture is going to look. But we're just going to kind of get a feel for it so far. So dy dx equals x minus 1. Now remember, dy dx means slope. Okay, that's what the m is. So let's say we started with 0, 0. At 0, 0, if I plug in 0 for x, what am I going to get? I'm going to get -1. Okay, so at 0, 0, my slope would be -1. So if I come to 0, 0, I'm going to basically estimate a slope of -1. And I'm going to do that for each dot. Of course, some of these things you'll get a pattern for. So let's see if we can't figure out a little bit of a pattern. If I look at 0, 1, well, since the formula is x minus 1, I'm not actually going to be plugging a y in. So I'm still going to be plugging in 0 minus 1, which is still -1, which tells me that anytime my x value is 0, my m should be -1. So that's going to occur all down the y-axis. Oops, that's not a very good drawing. Let's try that one again. So on each of these dots, I'm drawing a slope of -1 and I'm estimating it. It's not perfect. -1 and +1 are the easiest ones because they're directly 45-degree angles. But the rest of them, we're just kind of estimating it to get a feel for how it's going to look. Okay, so we know what's going to happen on the 0. So let's see what's going to happen on the 1s. If x is 1 and y is 0, then I'm plugging in 1 minus 1, which is 0, which is a horizontal line. So horizontal slope is going to be right here. You'll see that red? So if I did 1, 1, well, you can see the same thing's going to happen. The y actually never affects this slope. Only the x values do. So 1 minus 1 is still going to be 0. So anywhere that x is 1, my slope is going to be 0, which is a horizontal line, so I make horizontal lines. And then when x is 2, what's going to happen? When x is 2, it's going to be 2 minus 1, so my slope is going to be 1. So anywhere along the vertical line when x is 2, my slope is going to be +1. So I've got +1. And we've only done a little bit right here, but can you kind of see how this is almost like the bottom of a parabola right there? So we'll just kind of keep going. When x is 3, all of the x equal 3 values will be 2. So this is going to be slightly sharper. So I kind of say it's a little bit sharper than what I had at 1. And then when x is -1, my slope is going to be -2. So I'm going to have a slightly sharper this way. Alright, so then when x is -2, my slope would be -3. So that's even a little bit more sharp. And then when x is -3, my slope would be -4. So that's going to be the sharpest. So remember that you're just kind of putting it in there. It's not so much that it's going to be exact. All right, what does the slope field do for me? Well, it tells me that, let's say I started right here and I follow between the lines. It gives me the shape of my slopes, which allows me to graph this. So we can basically see the answer to this equation is going to be a parabola. And actually, we could solve this, because if dy dx is x minus 1, if you bring the dx to this side and integrate it, you would get x squared over 2 minus x plus c, which is a parabola. So it's going to have a parabolic shape to it. So if we can solve it, you're probably thinking, why do we need a slope field if we can solve it? Well, the ones we're practicing are going to have, some of them will be ones we can solve, but when it comes to integration, when it comes to taking a differential equation and making it into an integral, it doesn't always work. Just about everything is differentiable, but not everything is integrable. So we're going to look at this next one and see how it's different and see if this one gives us the similar shape. So if my dy dx, if my m is 1/2 y, the difference with this one, last time the slope only had x's, this time the slope only has y. Because even if I plug in 0, 0, the x value is not affecting the slope. So when y is 0, I would have 1/2 times 0, which would be 0. And so when y, anywhere that y is going to be 0, my slope is going to be 0, which is a horizontal line. So horizontal all the way across. Okay? Sometimes that will show us where an asymptote is going to be. I don't know if that'll happen here or not. Okay, so since we don't need the x, we'll just go down the line and we'll do the y values. So when y is 1, my slope would be 1/2. So everywhere that the y value is 1, I'm going to do a slope of 1/2. So it's kind of shallow. Just kind of like that all the way across. When my y value is 2, I'm going to have 1/2 times 2, which is 1. So across the 2's, my slope's going to be 1, which is 45-degree angle. That's the easy one, even though my drawings aren't great. When y is -1, I'm going to have -1/2 for my slope. So that's going to be kind of shallow going this way. And so that leaves me with when y is, what, -2? I don't think I went as far on this one, did I? When y is -2, the slope's going to be -1. So that's going to be 45 degrees, but it's going to be at an angle this way. This one's kind of hard to tell what's going on. But if we solve this, you'll probably see what it is right away. So let's try to solve this. If I were to solve this, dy dx equals 1/2 y. If I were to separate it and bring the dx to this side, I would have to divide the y on the other side. So what I would have is dy over y equals 1/2 dx. And if you integrate this side, you get natural log of absolute value of y equals 1/2 x plus c. So when I try to get y by itself for this problem, this would be an e graph. It's going to end up to be e to the y. No, I mean e to the x, sorry. Specifically, it's going to be 1/2 x. So if you know that's what your answer is going to be, can you see now how that's making that shape right there? And then if anything was underneath the x-axis, it would go that direction. So both of the first two equations we've done are ones we could actually verify and see what's actually happening because we can integrate it. But the last one we're going to look at has x and y together, and it's not going to be separable. So this is going to be something that we cannot solve, because we can't just subtract or add the y to the other side, because we'd still be left with it's hard to explain. Let me show you. If I move the dx to the other side, x minus y is together. We would have to distribute the dx to try to get them separated. So then I'd bring the y back over here, but if I did that, I would have dy minus plus y dx, so I can't get that y and dx to separate from each other. So since it's not separable, we can't just solve it. So instead we're going to use the slope field. So the slope field will at least give us an idea of what the picture would look like. And you would be surprised at how many things are not integrable. We're used to seeing all the things that can be solved because that's what we practice. But there's a lot of things that don't work. All right, so let's see what we can figure out here. If I use 0, 0, 0 minus 0 is 0. So at 0, 0, the slope is a horizontal line. I hope you can kind of see that. Maybe not. I'll change to red. Okay, at 0, 1, that would be 0 minus 1, which would be negative 1. So at 0, 1, the slope is going to be negative 1. At 0, 2, the slope is going to be negative 2. So that's going to be a little bit more, a little sharper. At 0, negative 1, my slope would be positive 1. So that's just going to be 45 degrees. So we're going to try to kind of run through this for all of them. If I did 0, negative 2, my slope would be positive 2, so that's going to be a little bit sharper angle there. All right, I'm going to erase the zeros and we'll go to the ones. When x is 1 and y is 0, that's going to be a slope of 1. When x is 1 and y is 1, that's going to be a slope of 0. So I actually see something that could be a pattern. So if you're following me, 0, 0 was 0. 1, 1 is going to be 0. 2, 2 is going to be 0. So this diagonal line, all of those slopes are going to be 0. If I do 1, 2, that's going to be negative 1. And 0, 1 was also negative 1. So if we go on the diagonal lines here, all of these slopes are going to be negative 1. That's useful. If I do 1, negative 1, I get a slope of what, 0? So I think I see something else that's going to happen, but we'll have to check that in a second. And then if I do 1, negative 2, my slope's going to be 3, which is much sharper. Alright, so I have a mistake here. 1 and negative 1 is going to be 2. So 1 and negative 1 is going to be 2. That makes a lot more sense to me. And I believe that's what this slope was too, so I think we're again going to have a diagonal situation. Alright, let's check some of the 2's. When x is 2 and y is 0, I'm going to have 2 for my slope. So, sure enough, that's a 2, and that's a 2, and that's a 2, which means this one's also going to be a 2. So along this diagonal right here, we have 2's again. And then if we do 2, 1, 2, 1's going to be a slope of 1, which is right there, which means that this was also a 1, and this was also a 1. Oops, I just moved to that. I didn't mean to do that. Well, darn. Okay, so 2, 1 was where? Right here. There, 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 there. 2, negative 1 would be 3. And this one was also 3. So we've got another diagonal. So if you follow the diagonals, you can see we can actually just follow each of the diagonals and see what we've got. So, for example, this slope here was negative, let's see, what was that slope? 0, 2 was negative 2. So negative 2, negative 2, negative 2. So sometimes it's tedious to do a slope field, but it's not a difficult process. All right, so there's a couple things I'm missing here, like negative 2, 0 would be a slope of negative 2. So right there. So since we know now that the diagonals are going to do the same thing, I'm doing negative 2 here and negative 2 here. As ugly as this thing is, I still can kind of see what the shape is. I hope you can too, but it's really, you can kind of tell that it's coming in like this and going up like that. It's got, most likely it's got like a slant asymptote to it. Alright, so let's try, I want to do this one over here. Negative 3, 2. So that's what? Negative 5. So these up here are getting more and more steep. And these ones over here are going to get more and more steep going this way. And then you have kind of a vertical, almost asymptote that goes through the middle there. Okay, so the purpose behind the slope field is just to get an idea of what the picture looks like. And I have a worksheet for you to work these problems on so to make it a little bit easier.